Hello students, myself Adarsh and I welcome you all to our YouTube channel. Today we will be studying on a very interesting topic, that is number system. And today we will be understanding, classifying and operating with different number systems. Basically, it is going to help to clear the concepts of the students of class 8th to class 6th. So let's get started. First of all, we will be looking on the natural numbers. This is the basic and very initial number system. So if we look into the definition of natural numbers, so basically these are also known as the counting numbers. Likewise, they start from 1, 2, 3 and goes so on. So as if we conclude natural numbers, so they can be written as and though they goes up to so on. The next we have is whole numbers. And one more thing, whatsoever number system we will be studying would be greater than the previous number system. Likewise, you are going to see in whole numbers, we add 0 with the set of all natural numbers. So it can be written as 0, 1, 2, 3 and up to so on. The next we have is integers. Till now, whatsoever quantity we had looking up to is basically a positive quantity. Now, we have also included the negative quantities. So you can see, likewise in integers, plus set of all whole numbers. This is how we conclude the natural numbers, whole numbers and integers. Now moving ahead, we will be looking to rational numbers and irrational numbers. Basically, the concept of irrational number belongs to 9th and 10th standard. So we will be discussing this topic. Now we need to look into the rational numbers. Now what are rational numbers? The definition says any number which can be written in the form of p by q, where p and q are integers. We have gone through the definition of integers, so we are very well known about it, and it also have some conditions. Likewise, q cannot be equals to 0, as well as p and q need to be co-prime. That means this is what we call as rational numbers. Where q cannot be equals to 0. This is because if we divide a number by 0, the result could not be defined. Meanwhile, as if we will look, apart from 0, there are other exceptions as well. We cannot include infinity as well. In some of the cases, when we include infinity in the denominator, the resultant is said to be not defined. Hence, for the generalized cases up to 8th standard, we do not include 0 and infinity into denominator, or else we are going to get an undefined result. Let us have some examples of rational numbers. So we can write any number apart from 0 and infinity. For an example, 1 by 2, 2 by 3. We can also include the negative quantities as well. Minus 3 by 7, minus 8 by 9, and so on. There are many examples of rational numbers. Meanwhile, what you can conclude, these P and Q are written, or we can conclude that these P and Q are co-prime to each other. That means their highest common factor is 1. Or else, if we take some quantities like this, so they are not going to have their highest common factor as 1, so they could be simplified. For an example, if I take 2 by 4, I can write this as 1 multiplied by 2, and 4 can be written as 2 multiplied by 2. The common portion of 2 would be cancelled out, and the resultant would be 1 by 2, resulting P and Q to be co-prime. I hope so. You have got this thing. Now, moving ahead to the definition of irrational numbers. So, basically, irrational numbers cannot be written in the form of P by Q, where P and Q are integers and Q cannot be is equals to 0. We will be discussing this topic of irrational numbers later in our upcoming lectures. Moving ahead with rational numbers. So, we have a question over here which says we need to write 5 rational numbers in between 1 and 2. So what we can do? We have and these questions are based on NCERT. So you can by seeing these questions, you can solve your NCERT questions as well. We have 1 and 2. So we can write it as 1 can be written as 1 upon 1. It would be concluded as 1. 2 can be written as 2 by 1. Now I am multiplying both these numbers in numerator and denominator. Simply whatsoever quantity you think about. Likewise, I am taking 7 over here. It is not going to affect, as we have seen in our previous slide, the common quantity. The common quantity does not have any effect on the original quantities. It would be cancelled out, so we can easily multiply and divide by a single number in numerator as well as denominator. So the 1 and 2 will become 7 by 7, and here it will become 14 by 7. If you will draw these numbers on a number line, I am writing the original quantities on upward side and the concluded quantities on the downward side. Now we need to move from 7 by 7 to 14 by 7. Likewise in a manner, 7 by 7. Now this would be 8 by 7. This would be 9 by 7. 10 by 7. 11 by 7. 12 by 7. And 13 by 7. After 13 by 7, the 14 by 7 quantity would be originally known as 2. So, how many quantities we have got over here? 1, 2, 3, 4, 5 and 6. Basically, we have got 6 quantities in between 1 and 2. Now, you can write whatsoever 5 quantities you wish to write in between 1 and 2. Likewise, I can write the quantities are, or the 5 numbers, basically rational in between 1 and 2 are 8 by 7, 9 by 7, 11 by 7, 12 by 7 and 13 by 7. You could also have included 10 by 7 instead of any of these quantities. The resultant will have no effect. Now we need to move ahead and we need to look forward with the properties of number system. Basically, these number systems work with some properties. The name of the properties are closure, commutative, associative, distributive, additive and multiplicative identity. One more thing, wheresoever you will look for the word operation, here operation means it could be addition, subtraction, multiplication, and division. For some specific properties, these operations are defined. Meanwhile, if we are discussing some properties, we need to look with all of these operations and we'll see which number system follows the following of the properties. So let's move to our first property, that is the closure property. Now what does this means? The closure property states that the result obtained by any two numbers within an operation should be also within the set of particular number system. Now look, as per our definition, first of all we need to opt out any one of the particular number systems. We have seen natural numbers, whole numbers, integers and rational numbers. Let us start with the natural numbers. Our very first step is complete of choosing any particular number system. So we have opted for natural numbers. Okay. Now again, by the definition, we need to choose any two numbers within an operation should also be within the set of particular number system. Now let us choose any of the two natural numbers. Let us say 1 and 3. We have opted with these two numbers. Now we need to choose an operation as well. We have 4 operations. addition, subtraction, multiplication, and division. If we will look 1 operation 3, or we can say like 1 plus 3, it concludes to 4, which is also a part of number system. So we can say that natural numbers hold closure property for addition. Got this thing? Now moving to next operation, that is subtraction. If I will write 1 minus 3, the resultant would be minus 2, and we know that the negative number is not included in the natural numbers. So we can say the natural numbers do not hold the closure property with respect to subtraction. Moving to multiplication, 1 into 3 would be 3. It already lies within the natural numbers. So the basic is the natural numbers hold closure property with respect to multiplication. And if we will look to division, 1 divided by 3 would be somewhat around 0.33, and this does not lies in natural numbers. Look, this is a quantity which lies between This is a quantity which lies between 0 and 1. It is greater than 0 but smaller than 1. But our natural number starts only with 1 and not the number smaller than 1. Hence, we say that the natural numbers do not hold closure property with respect to division. Got this thing? Now what you have to do is you have to apply all these 4 operations with rest of the number systems, particularly with whole numbers, once you have completed this, you need to move to the next set, that is integers. And the next set would be rational numbers. You need not to apply this property to irrational numbers. Okay, you need to apply these properties only to such number systems. Okay, now moving ahead, we have commutative property. What does this commutative states, or what does this means? So the commutative property states that the order of numbers do not change the sum or product. Now what does this means? Look, here the operation is already defined as the sum or as the product. Okay, what does this means? Sum basically means addition. Product means multiplication. Now what does this states? That orders of number does not change their sum or product. For an example, considering any of the number system and taking any of the two numbers, for an example, if I take 5 and minus 1, this basically belongs to the set of integers. Now, if I add or sum both of them, 5 plus of minus 1, this will basically conclude to 5 minus 1, and that is equals to 4. Okay, now how does this happens? So it is basically written as the 1 is hidden over here. To open this bracket, we will be multiplying the inner quantity with 1 with the operation. So what we will get? Plus of minus 1, and this will conclude as 5 minus 1. Okay, so this will get back u2 like this. Okay, if I change the position, now if I will open the bracket, so it will be basically minus 1 plus 5. We can also conclude or see this by an activity. Let's have a look on it. Suppose we draw the number line. We all have seen this. The positive quantities are on the right hand side of the 0. Meanwhile, the negative quantities are on the left hand side of the 0. To operate addition or subtraction, we need to move either left or right. Now what does this means? Look, likewise, we have 5 of minus 1, right? 5 plus minus 1. So look, if I say 5 plus minus 1, this results to 5 minus 1. Now how do we conclude this? We have 5 over here on our representation of number line. Now if we need to subtract anything, we need to move to the left. Now basically 5 minus 1, this would be the result as 4. And as if I take minus 1 and then I need to plus 5 quantities to minus 1, so I need to jump to the right side. So basically if you need to subtract anything, you need to move towards the left of that particular quantity, and if you need to add anything to a particular quantity, you need to move towards the right of that quantity. I am sharing this concept just because these lectures are also for 6th and 7th standard students, so it would be very useful for them. Now look, when I will take minus 1 over here and I need to add 5 quantities, so I need to move 1, 2, 3, 4 and 5. The result in both the operations is equals to 4 only. So this is what we mean by the commutative property, that the orders of numbers do not change with the sum or product. You can also look for multiplication in the same manner. Moving to the next property, that is associative property. Now what does this property states? The associative property states that the way numbers are grouped does not change the sum or product. Okay. Now for this grouping we need to consider three numbers or three quantities, whatsoever you prefer to say. Likewise, I am taking 1, 4 and 3. Okay. Now again, the operation is specified to sum or product. Apart from these two operations, if you go to subtraction or division, the associative property would not hold for the particular number systems. Okay. Now look, I may conclude it as for sum or product. First, let's have a look for sum. In the first case, I have grouped these two quantities. In the second case, I have grouped these two quantities. You can easily see that the grouping of the numbers has been different in both the cases. Here the result is 8. Now let's have a look for this one. So we can easily see and look that grouping does not affects the result of the given particular quantities. The same thing happens with product as well. You can try it on your own. I am giving you three numbers. These are -2, 1 and 5. What basically you have to do is you need to product these quantities by grouping them by each of them and then have a look on the result. Okay. Now let's move ahead to the next property, and that is distributive property. Okay. Now what does this distributive property states? And it says that the distributive property connects addition or subtraction and multiplication. That do means the addition or subtraction would be connected with multiplication, and it states that multiplying a number by a sum or their difference is the same as multiplying each addend subtracted separately and then adding subtracting the products. Now what does this definition means? Let's have a look in mathematical terms. Suppose I have three numbers a, b and c. Okay. Now this property means that if I add or if I subtract any of these numbers and then multiply their product by c, it is going to give me the same result as if I had multiplied these quantities and then applied the particular operation. Let's consider an example as well. Let's have any of the three numbers. I'm taking small quantities over here. Okay. Or what shall we do? Now it's okay. Now these three numbers where we can conclude this as A, this as B, and this as C. And then we can apply it in any of these two expressions. So applying it to the first expression on the left hand side, taking it to the right hand side, you can easily observe that the result we have obtained is equal or same. So this is what does we mean by the distributive property. I hope so you have got this thing. Moving to our next properties, we have additive and multiplicative identity. These are the very basic identities or property you can say. It states that the identity property states adding 0 or multiplying 1 does not change a number. It's a very basic thing. If you consider a number A and add 0 to it, the result obtained would be obviously A. If you consider a number B and multiply it by 1, it's going to give you a resultant as B. Now, suppose, let us take this example. We know that within an equation, if two quantities are in multiplication and we need to transfer any of these two quantities to the other hand of the equation, we need to simply change this operation by division. What does this means? If I put 1 over here, consider B over here, and if I need to substitute this B from over left hand side to right hand side, I need to change this multiplication into division and I need to write that quantity. And we had seen in our previous slides that the equal quantities are cancelled out and the result obtained is 1. Hence, we can also conclude this thing in this manner as well. So these are the basic properties which we apply to the whole number system, and then some results are obtained. Okay, so that's all for this session in class. Now from the next class, we will be looking ahead to irrational numbers. I hope so you have liked this session. In the next class, we will be moving ahead with the concepts of irrational number. Thank you.